Okay, welcome back, folks. I'm just going to do some commentary here, 3.11 in your CASEL curriculum. So if you want to just read along here, I'm going to go through this. Benjamin Franklin's plus and minus notation. Movable charge is normally present in all conducting matter. Adding some charge to a normal capacitor plate will result in there being more than the normal amount of charge in the plate, while removing some charge will result in there being less than the normal amount of charge in the plate. So in other words, everything that's conducting, every conducting material naturally has charge on it that can move around. If we charge up a capacitor plate, we make one plate have more than the normal amount of charge and the other have less than the normal amount of charge. Benjamin Franklin came to the same conclusions when he did his pioneering work in electricity a few years before the American Revolution. Franklin is the person who first used the plus and minus symbols in electricity. However, he did not mean them in the same sense of the modern explanation. He definitely was not referring to positive charge and negative charge. He was simply talking about the quantity of one kind of charge. He used them to represent these two conditions. Positive represents a more than normal amount of charge, extra charge, and negative represents a less than normal amount of charge, missing charge. In the next section, we will be using these symbols with the same meanings Franklin gave them. Now in section 3.12, we learn a little bit more about energy. The term energy is probably one you often use. However, if you attempt to define it, you may find it difficult to do so. Energy is best defined as an invisible substance that can be stored in matter and transferred to other matter. And it's what gives matter the ability to make something happen. We have identified a number of things that happen in circuits. Charges move, bulb filaments become hot and give off light. What is the source of the energy that makes it possible for these things to happen? What are some of the ways to think about this energy? In most of the circuits we've observed, the source of the stored energy has been the battery. In some circuits, however, there was no battery present. When a capacitor discharges, it can make the same things happen, so it must also have been a source of energy when it was charged. In circuits where a Genicon was used, the source of the energy was not the Genicon itself, the source of the energy was the person doing the cranking. The cranking action transferred the energy stored in your muscles to moving charges and lit bulbs. The Genicon can be thought of as a pump, like a pump putting air in a tire. Energy is being transferred into the tire and can be felt as a harder tire, more pressure. You know that batteries eventually wear down and become dead. This means that they no longer have sufficient energy stored in them to make something happen in a circuit. Some batteries are called rechargeable and can be reused. This is an incorrect term, however, since the battery's task was never to supply charge to the circuit. The charge was already there. These batteries would more likely be called re-energizable. Now look at this figure. It shows the source, which may be the battery, for example, or the Genicon, and the receiver, which may be, say, the light bulb. The energy is being provided by the source and received by the receiver, but the charge is just recycled. It's just pushed around and around and around through the circuit. In a circuit, charge originates in every conductor and constantly recycles around the circuit. However, energy leaves the energy source where it is stored and travels one way to a receiver. Energy can leave a circuit as heat or light energy from the bulbs, the receivers. The energy source might be the stored energy in a battery, stored energy in muscles used to crank a Genicon, or other sources. In addition to a transfer of energy, there is a transformation of energy from one type to another. For example, when charge in a circuit carries energy from the source to the receiver, some of the electrical energy is transformed to thermal energy, and the wires become warmer. Remember that? And when energy is transferred to a capacitor, the energy shows up as a difference in electrical pressure between the two plates. And when the charge carries energy to a bulb, some of the electrical energy is transformed into light energy. Through either heat or light, the energy is leaving the circuit.